Hi friends, I hope everybody is doing good. So today I have got a new topic over here, Venn diagrams. So you might have gone through my video of sets earlier, right? I have basically posted a video on sets, the basic of sets and everything. Now we are going to look at Venn diagrams. Venn diagrams are basically the pictorial representation of sets. That's how you define it. So with the use of Venn diagrams, right, solving problems becomes much more easier. If you look at large sets like this, right, you may miss out certain times. I have basically reviewed my video from yesterday. I have made some mistakes in some of the areas. So let's see how we can fix those kind of mistakes, okay, with the use of Venn diagrams. So let me draw. Now let's take this example and understand Venn diagram very nicely. Okay, so let me help you understand this. So you have a universal set which has 9 elements, numbers 1 through 9, and A, B and C are subsets of the universal set. Okay, so now if I want to draw the Venn diagram for this particular set, right, for this particular example which has been given, look at how I'm going to approach this. The first and foremost thing is that the universe is represented by a rectangle. Always remember, it is represented by a rectangle like this. Okay, and it's marked here. It's marked outside that this is the universe. Okay, now look at A, B and C. Do you see any common items between A and B? Yes, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3 are common. So basically what I'm trying to say is that if you look at it, if I draw the 3 sets like this, right? Suppose this is A, okay, and this is B, okay, and this is C, right? These are the 3 sets which we have. I can denote them as like this. So even before drawing the picture, right, I need to understand if these two are linked. So if you look at it, there are common items 1, 2, 3 over here in A and 1, 2, 3 in B. So they need to overlap between each other. So that's the reason why I was looking for it. Similarly, look at B and C. Do you have an overlap? Yes, I have an overlap of 3 and 7. 3 and 7. So there will be an overlap of 3 and 7 over there. So, and finally, between A and C, do you see an overlap? 3, 4, 5. Yes, you have an overlap. So I am putting it that way. Okay. If not, right, what will happen if these sets are not overlapping with each other, right? The diagram will become like this, right? If this is the universe, right, the diagram will become disjoint sets. You have to put it like this. Look at it. They don't overlap with each other. There are no common items. So I need to understand before putting the diagram. Okay. Now let's go ahead and populate the figure with the numbers. So your life becomes much more easy when you actually go ahead and solve problems related to sets. Okay. Now, can I first and foremost thing what you need to do is that when you're populating, right, you need to look at the common items between two sets. What are the common items between A and B? It's 2, 3, 1, 2, 3. So 1, 2, 3 basically will come here. Even before going there, what I would suggest is that what is this area over here? What is this called? If you look at it, right? This one. This is the common portion of A, B and C together. This is the common portion of A and B. This is the common portion of A and C, and this is the common portion of B and C. So now the first thing when you populate a Venn diagram with values is to look at this one. You go inside out. Remember, you go inside out always. So this one over here, what is this one? The number which is going to, the element which we are going to put it over here should be present in all 3 of them. So which is the number which is present in all 3 sets over here? If you look at it, there is a 3 here, there is a 3 here, there is a 3 here. Anything else? Any other number? 1 here, 1 here, no. 4 here, 4 here, 4. There is no 4 over there. 5 here, 5 here, there is no 5. 7 there, 7 there. 8 is only here, 9 is only there. So there is nothing else. So I'm going to put the number 3 over here. because it is common to all the three sets. So 3 has been taken care of. You don't have to worry about 3. 3 has been taken care of. Now look at A and B. What are common between A and B? It's 1, 2. Look at it. Now this entire portion, if you look at it, right, this entire portion is common to A and B. That's why we have 1, 2 and 3 put in that particular fashion, because 1, 2, 3 is common between A and B. Look at it. Does it signify that when I put the value? Yes. Okay. So 1 and 2 taken care of in both the sets. Now what are you left with in A? 4 and 5. 4 and 5, if you look at it, right, 4 and 5 is common between set A and set C, but not in set B. So 4 and 5 will come here. Look at it. 4 and 5, it's the common area. Now look at what are common between A and C. 3, 4, 5. So 3, 4, 5, 3, 4, 5. All taken care of. Good. Should we move forward? Now what is common between B and C? B and C, there is a common element called 7 over here. B and C. So should I put it? Now look at it. If I cross 7 over here, what was common between B and C? 3, 7, 3, 7. So I have included 3, 7. If you look at it, it's included over here. Now what are we left with? Do we have any common items? We don't have any common items. So 9 comes here. 9 is only in B if you look at it, right? And 8 is only in C. Okay, so have we covered all the numbers? Did we cover all the numbers? If you look at it, count it: 1, 2, 3, 4, 5, 7, 8, 9. There is 6 missing. Where does 6 go? Where does 6 go? 6 sits in the universe. 6 sits in the universe. Remember always. So all 9 numbers have been taken care of, right? This is how you plot a Venn diagram. Now let's go ahead and start. Now I don't need this information because I have taken care of plotting it. I don't need this. So in Venn diagrams, what they will do is that they will give you this diagram and they will ask you to start finding out values. For example, let's get started. So find the following. Find the following. Okay, right? Now first one, say I want to find A union B. Can you tell me the values of A union B from there? What is A union B? What do you mean by union? Union is either in A or in B. So whatever elements you see in A and B, you need to list all of them. So look at it. It's 1, it's 2, it's 3, right? Because all these elements coming in this particular boundary, let me use a different color so that it becomes very easy. So look at it. They should come in this particular boundary if you look at it. Right? Though that is A union B, that is how you're going to shade it. If they want you to, if they ask you to shade it, it becomes 4, 5 and 7, 9. Got it? Now, second one, B union C. B union C. Can we go ahead and find it? What are the elements do you have? B union C is this one and this one. Look at it. So it is again 1, 2, 3, 1, 2, 3, 7, 8 and 9. Look at it in the order. If you look at it, those are the elements which are there in B and C together. Okay. Similarly, if you want to find A union C, it will be this one and this one. So it's again 1, 2, 3, 4, 5 and 7 and 8 both. Look at it. That is what you get, right? That is what you get. Now go to the next one. Can we do the intersection ones? A intersection B means only the common items between A and B. What do you get from the figure? It's 1, 2 and 3. Look at it. This portion is this portion is A union B, right? Similarly, if I want to go and calculate B intersection C. What is B intersection C? This is the area. It's 3, 7. 3, 7, right? Go ahead. A intersection C. What do you get? A intersection C is this one. 3, 4, 5. 3, 4, 5. Right? This is how you're going to do it. This is what you need to do it. Now, one more thing over here. If you want to go ahead and calculate B minus A, can somebody tell me what is B minus A over here? Can you guys guess it? So whenever you're getting these kind of problems, right, B minus A, what you need to do is that just close A. You don't need A. They are saying that remove A from this one completely. So they are asking you to remove this one completely. This one. So what are you left with? You are left with only 7 and 9. 7 and 9. Right? That is what you are left with. Similarly, if you want to do A minus B. Now they are saying it's the reverse one. They are saying that remove B completely. What are you going to remove? You remove the entire B. So what is left in A? It's this one only. If you look at it, it's 4 and 5. 4, 5. Make sense? So using a Venn diagram, your life becomes very easy to solve these kind of problems. Let them throw any kind of problem at you, you should be able to do it. Now, how do you write this one? The number 3. If they ask you that, can you please represent 3 in the form of this one, like this? How can you represent that? You can do that. This 3 is nothing but it is A intersection B intersection C. Look at it. Because it is there in all the 3 sets. It resides in all the 3 sets. So that is what it is. Got it? Yeah. So similarly, if you want to do say C minus B or B minus C, you should be able to do it. But whatever they want you to remove it, right? Suppose they say B minus C, you need to basically close this part completely. You close the C completely over here. So what are you left with? 1 and 2, that is B minus C. Right? If they ask you to do C minus B, you close B completely. You close B completely, you have 4, 5 and 8. Okay? Good. Very clear how to basically approach a particular Venn diagram problem. This is how you draw a Venn diagram and you get the values out of it. Okay? So let me take one more example and explain it. Yeah. Let's look at this example now. Okay? So they have given a Venn diagram over here. They have given the details. They have populated all the values inside it. And they are asking us to calculate everything like this. So even before you get into the problem, it's always better to read the diagram properly so that you understand what is there. Now if you look at it, there is a universe which is a rectangle. There is a set A, right? Set A outside and set B is inside A. So you need to basically call out clearly that A is the subset of universe, right? And B is the subset of A. Look at it. In turn, it is the subset of the universe, right? A is the subset of. So that's how you see it, right? Now, if you don't understand the picture well, right, it will become very difficult to basically go ahead and solve the problem. Remember, always understand it and move forward. Okay, let's get to one by one over here. So now, what are they asking us to find? Find the value of A. What do you have in A? What is the set for A in roster form? What all alphabets do you have in A? You look at it, right? You have to put everything, whatever is there here, including elements of B also. So you start with C, because if you want to put it alphabetical, C, D, E, F, G, H, and I, if you look at it, right? So those are the elements which are part of A, the entire A, right? Now part of B. What are part of B? There are 3 elements, E, F, and I. Make sense? Are you in agreement with me? Okay. Now, what is A complement? I have told you earlier, right? whenever you see this A complement, single slash above, right? What do you need to do? You need to consider the elements which are not part of A, not part of A, but from universe. So what are the three elements you see in universe? It's A, B and J. Look at it. A, B and J. Right? Similarly, what is B? B complement? Forget about B. Forget about B and you need to include all others, right? Don't include the elements of B, include all others. So start with A, B, C, D, E, F will not come. It'll be G, H, I and J, because J is outside. Look at it. J is in the universe. If you look at it, right, A, B and J are in the universe. They are not part of sets A and B. Okay, clear? This is how you approach. Now, A minus B. A minus B. So what are you going to do? You're going to remove the elements of B. They are saying that I don't want B, I want only A. So what are the elements there in A only? It's C, D, G and H. Right? Makes sense? What is B minus A? Can you do a B minus A over here? It's not possible because B is a subset of A. Right? You cannot remove A. B is part of A. So there is nothing you can do about this one. So this will become a null set, or you can write it this way also, an empty set. Remember that one always, to read the problem properly. Okay? So now next one, A minus B complement. What do you have in A minus B over here? A minus B, you have these elements, right? What is the complement of it? It's the other side of it, other side of A. So you need to include all the elements which are outside of A, right? Basically not these four but others, right? It will be, now if you look at it, can you include these? Can you include these? You cannot include them also. A consists of A and B. Remember always. A and B is within A over here. So in this particular case, what happens is that you're going to include only A, B and J. Because what you're trying to do is that you're closing A completely over here. You're closing A completely over here. So B is part of A, so you're not going to consider those. Now B complement A. B minus A complement. B minus A complement is a null set. So B minus, it's a null set, right? So it will include everything. It will include everything other than, yes, it will include everything whatever is there in the universe. So it will be A, B, C, D, E, F, G, H, I and J. Everything it includes. So make sense over here how to basically read a Venn diagram and answer the questions in this particular fashion. So the first step is to understand the Venn diagram properly, then only go into the question. Okay? Yeah. Let's look at another example. Right over here, there are three sets. You have a universe and there are sets A, B and C, and they are overlapping with each other in that particular fashion. They have given the diagram in that particular case, and these are the elements of A, these are the elements of B, these are the elements of C, and these elements are in the universe. They are not part of ABC. Now let's go one by one and start solving them. They are asking us to find A union B. A union B means elements which are there in A or B. So union means you need to take into account everything. So it will be A, B, C, D, J and K. Look at it. Done. Go to the next one. B intersection C. Do you have anything in B intersection C? This is the area they are talking about. This is the area they're talking about. You don't have any elements, so that's a null set. So similarly, the next one, they are asking us to find out C minus A. Now C is there and they are asking us to remove A from it, right? This is C and they are asking us to remove A from it. So what are the elements left here over there? So it will be H, I and Q. Those are the three elements because I don't want to consider any elements from A, between A and C. So I am removing that and that's only. A minus B. A minus B, you remove B, close B completely, close complete B completely, you are left with ABC. A, B, C. Make sense? Easier? Now, next one, what are they asking? They are asking us to find first you need to find B. Whenever you have these kind of things, right? It's like that algebra thing, what we do, Bodmas. First you need to solve this, then you pitch it against this one and find out. So first and foremost thing, let's find out what is B minus C. Here what you need to do is that you need to find out B minus C. What are the elements in B minus C? If I am taking B minus C, they are asking us to remove C completely. So you are left with D, J, K. B minus C is D, J and K, right? Now they are asking us to do a union of this one, this set and A, right? This one and A. So when you do that, what do you get? When I do that, I have to include all the elements which are there in A, B, C, D, and there are two elements J and K. Easy? Now you understood how to approach it. Always do this one first and pitch it against A and get the value of that one. Similarly, this one, C intersection B. C intersection B. Do you have anything over here? It's a null set. Look at it. C intersection B is a null set over here, right? This is what it is here. B intersection C and C intersection C are the same. Now they are asking us to do a union with B. They are asking us to do a union with B. So what do you have? Null set with a B will be JKD. Look at it. It will be D, J and K. Look at it. Simple. Simple. How to do it? Now A union B, we already have it. These are the values. Intersection C. Now what they are asking us to see is that between this one and with C, what are the common elements between these two? Can you figure out any common elements? Look at it. A union B, you have A, B, C, D, J, K, and intersection C, you have H, I, Q. Do you have anything common between these two? I don't see anything common, so this becomes a null set. There is nothing common between those, right? Now, B union C complement. B union C. So, for that, you need to go ahead and calculate B union C. Let's calculate B union C. What is B union C? B union C, if you look at from the figure, right, even without calculating, I can do it. They are asking us to calculate B union C ka complement, right? So I am going to remove B union C completely and include all the elements which are left. So it will be A, B, C, right? A, B, C and the elements in the universe. That is M, N, L and P. That is what it is. Look at it. Right? Makes sense? Okay. So let's move forward. There are another two. Let's do that. Okay. So now what are they saying? A union B minus C. What did you get? A union B. If you look at A union B, you're going to get all these things. All these things over here. And they want us to remove C from here. So what do you get? A union B, you have A, B, C, D, J and K. Because you want to include this and you don't want to include anything from here. C. So I removed C from there. Right? So now B minus A ka complement. B minus A. B minus A, what do you get? B minus A is only JK. Look at it. If I remove A completely, it's only JK, but they are asking us to get the complement of that. So barring JK, you have to write everything. So it will be A, B, C, barring D also. D also will not include. Okay, A, B, C. Then you have H, I, Q, and then you have P, L, M, N. P, L, M, and N. How is it simple? Right? It's very simple. You need to just visualize it properly and understand the question properly, then you'll be able to do it. Whenever you get these kind of things, always solve it in that Bodmer's rule. Do this one first, and with this one you pitch it against this one and get the answer. Right? Now let's look at the cardinal number formulae which we have studied in sets earlier, right? To see by using the Venn diagram can we prove these formulas to be correct, whatever formulas we have learned, right? You remember, if there are two sets A and B, you have that the cardinal number of A union B should be equal to the sum of the cardinal number of A, cardinal number of B, and you subtract the cardinal number of A intersection B. That is the formula which we have learned. So let's look at it and try to solve this one. So now, what is the cardinal number of, first we'll take LHS. LHS is left hand side is N of A union B, right? Let's go ahead and find out that A union B, what is A union B over here? How many elements do you have? You have 1, 2, 3, 4, 5, 6, 7, 8, 9. It includes all the elements, so that should be equal to 9. N of A union B should be equal to 9. So now RHS, let's look at RHS, find out the values of everything in the RHS. RHS, you have N of A. What is the cardinal number of set A? If you look at only A, right, completely, you have 7 elements in that. So that becomes 7. Similarly, N of B. If you cover B completely, how many do you have? You have 5 elements, right? Similarly, N of A intersection B. How many do you have in this particular common area? It's 3. Now, if we put them all together in the formula, it says 7 plus 5 minus 3, which is equal to 12 minus 3 is equal to 9. So therefore, your LHS is equal to RHS. So this formula stands. We have proved it using a Venn diagram also. We have proved this yesterday by using sets. It will work out for both of them because sets are the only things which are being shown as Venn diagrams. And from Venn diagrams, you can put the roster form of a set also. So it will work out. So similarly, let's try out to do this for 3 sets, right? For 3 sets. Yeah, similarly, we'll do it similarly and put the values and check that everything is working fine over here. Okay, so N of A union B union C will have everything, all 3, right? So there are close to 9. This becomes 9 over here. Let's put it as 9 on the left side is equal to, what is N of A? N of A, look at A, 1, 2, 3, 4, 5, 6. N of A is 6 plus N of B. Look at B completely. 1, 2, 3, 4, 5. It is 5. Right? Plus, I'll put a plus over here. C. Now look at C. 1, 2, 3, 4, 5. Again 5. Right? Now you have to start with the minus ones. N of A intersection B. How many do you have? 1, 2, 3. It is minus 3. A intersection C. A intersection C, you again have 3, minus 3. B intersection C, you have 1, 2, 3 again, it's minus 3. And then the last one, A intersection B intersection C, which is the middle portion of it, which is 2. So let's add the left hand side completely. 6 plus 5 gives you 11, 11 plus 5 gives you 16, 16 minus 3 is 13, 13 minus 3 is 10, 10 minus 3 is 7, 7 plus 2 is 9. If you look at it, 9 is equal to 9. So we were able to prove this one also, that it holds for Venn diagrams as well as sets. So these two formulas are key. If you remember, you are able to do a lot of problems very simply. Okay.